My name is Maxim Tyukov, and I'm tools engineer in RingCentral company. My main working field is monitoring of RingCentral infrastructure, and currently I'm busy with building high-level monitoring solution for this company. RingCentral provides our customers a cloud-based PBX telephony service. Besides of that, there are many other services like fax-related services, like mobile application services, web services, and so on. And currently in total we have about 20 services. And all of them should be monitored 24/7. Actually, let's talk about service health monitoring and how to build it. On presentation before, it was mentioned about service health monitoring and the service health dashboards a little bit, so I will go deeper in this topic. During my presentation, we'll talk about service health monitoring goals. We will discuss how to improve information delivery and how to visualize information delivery. Then we will see how to build service health monitoring in Zabbix, how to build multi-level monitoring approach, how to build items hierarchy, and then how to set service state criteria determination. After that, we will see how to build main dashboard in Zabbix, how to visualize it, how to create submaps, which behind the scene, how to create dependencies between them. And the final point, we will see service health dashboard in action on a real working example of RingCentral and discuss all advantages and disadvantages of implementation of this in Zabbix. Zabbix is a telephony company, so all examples which I will describe about telephony services based about voice over IP based on session registration protocol. So the main goal of high-level monitoring of service health monitoring is immediate and accurate detection of service outages. Usually, we see in Zabbix many alerts about some operation system events like a CPU high load or number of processes too high or services NMP stopped or some tracking of application errors. And all of them don't clarify the situation. Does it affect your service or not? And it won't help us to estimate risk accurately, to make a right and fast decision. So high-level monitoring provides us possibility to set high-level triggers and to see what is going on a service level. Actually, Service Web is one of the RingCentral services. And here, on example, we can see real picture. And here we can see that Service Web login failed. And that means that our customers can't log into Service Web. And it becomes clear for us that this service is affected. It's much better, but it's still not enough because best way to deliver information is a simple visualization. So the best approach is visual dashboard. That's it. This is a real dashboard of RingCentral company. From the left side you can see our services which we provide for our customers, and on the right side you see the grid with the services health. And now it becomes absolutely clear which service is affected and which unit is down. Actually, there is a unit. I hide it from you. And now we can make a decision to execute switchover to reserved unit, for example. And only after that we will go deeper and see what is going on really. Was it a CPU usage or a lack of memory resources? So let's see how to build this dashboard. When we talk about high-level monitoring, we also mean some items, some kind of items and alerts in Zabbix. But to build these alerts, to understand the essence of these items and alerts, we need to create multi-level monitoring approach. And that is multi-level monitoring architecture. It's built using RingCentral example, very close to real architecture. We can divide monitoring into different levels. It depends on our needs. For example, it may be virtual machines and hardware data, or operation system data and application data. But for service health monitoring, we divide into 3 levels. It's a host level, it's a pool level, and a service level. Usually production system consists of many hosts, and we collect data from each. Different data, and it doesn't matter which way we use. It can be Zabbix agent, custom parameters, SNMP protocol, external check, and many others. It doesn't matter. All of this is a host level data because we collect it from each host. Hosts with the same role are combined into pools. For load balancing or for redundancy. So to see the data on a pool level, we need to aggregate data from each host in a pool to see the data on a pool level. And then we see, and when we have the data per pool, we can aggregate it to the upper level for service. Let's take an example of inbound calls forwarding. This service provides our customers to receive call, to handle it according to customers' answering rule, and to forward outside to their mobiles. So to receive call, we need to receive it via inbound proxy. Then we need to handle call in a call handling pool. That's it. And then we need to forward this call outside via outbound proxy pool. And then call is established, we forward media traffic via media pool. So this service depends on 4 pools, and all pools should be operational to provide the service. To understand what data we should collect here, what data we should aggregate here and on the service level, we need to classify data. For service health monitoring, we classify data into 2 types. It's quantitative data and the functional checks. I'll begin from functional checks. Both of them can exist on all levels. So currently in RingCentral we use functional checks on a host level. The main purpose of functional checks on a host level to verify if hosts and application on this is operational. For example, for a web service, it can be a simple script like request some URL and handle response is it 200 or 404, for example. Also, pool and service level checks can be used. For example, pool level check can be used to check a pool. It requests a virtual IP of this pool, IP of load balancer, and due to this check we can see if a load balancer works good. And a service level check is a full emulation of user activity. It works only with front end. And when we see fail, we can see what's going on inside. And from our best practice, these checks can help us to find bugs in the system, hidden bugs. So quantitative data also exists on 3 levels, all levels. Usually we collect on host data different operation system data like a CPU, memory, I/O, and so on. And application data like responses from web server 200, 400, 500. Concerning telephony services, it's a number of lines busy or media ports open, and so on. When we have this data, we can aggregate it on a pool level. And here I would like to notice 2 main measures. It's a number of hosts live in a pool and the capacity of the pool. Number of hosts alive in a pool can be easily calculated when you have a functional checks on a host level. Better to use binary data from them. Because, 1 for OK and 0 when fail, and then you can aggregate this binary data and to understand how many hosts are alive in a pool. And in the same way, we can calculate pool capacity. For example, we can calculate number of telephone lines busy in all pool using aggregated items. And then we have the data on a pool level. We can calculate the service level data. Here I also want to notice two main measures. It's service capacity and service health. So let's see examples of items, how to create them. So there is example of functional checks. The main items here is a login to site and script sign in. Actually, both these checks are executed as sign in to the website or service site, and with the different ways. It doesn't matter how, and returns 1 if OK and 0 if failed. If you use such checks and you need to receive more information, more additional information, you can use not only binary data but text data, like here, just for additional information. If you have a text data, it can be easily converted to binary via additional calculation item with a string function, like here. This item will return 1 if this string exists, and 0 if not exists. So when we have such items for functional checks to understand how many pools are alive, or how many hosts are alive in a pool, we can aggregate this data with items of type group aggregated using function group sum. And here is 2 items. First one is very simple. It just handle ICMP ping response 1 or 0. And the second one based on a sign-in script. So when we have such items, we can understand how many hosts alive. If all of them are returns 0, or returns 1, so that means all of them are alive. In the same way, we collect another data group aggregated data, like a number of IP lines free. Actually, TAS is a kind of telephony server. So we collect IP lines free in all group, in all pool. And then we have number of hosts alive in a pool and the number of IP lines free. We can add to mix calculated item. We can calculate load average. We can calculate number of IP lines free in percentage or anything other. That's up to you. Let's see the formula. That is. Here we divide. Yes, it's very difficult. Here we divide number of IP lines free. That is item. Trust me. Number of IP lines free into total number of IP lines. And then we will see number of IP lines free in percentage. And in the same way, we can create many other items for other pools and to see how our pool are loaded. So that's how it works. When we have all data on a pool levels, we can aggregate it on a service. Currently, we don't use service capacity in RingCentral. So here I just want to show you a simple approach how we can get it. There is two formulas. It's really simple. I just get an average from all pool loads. And if lots of pool increase not evenly, you can add weights, for example. And it can be easily calculated with calculated item types. So, but we don't use it yet, so just to show you how it can be. And we use service health logic determination. We'll take as an example inbound calls again. This service depends on 4 pools here. And each pool already have data on a pool level, and the appropriate triggers are set. Critical triggers, because we don't interested in any informational or warnings. So when one of the triggers changes their status to problem, the pool becomes problem. And that means that inbound calls are affected. So this simple logic is provided us by Zabbix standard maps. So from this point, we can go with in and out in different ways. We can create a standalone web application which will get data from API about all this, or we can use the Zabbix maps for building dashboard. So let's talk about visualization in Zabbix. What is a service help dashboard in Zabbix? This is a simple map. This is a standard map, but with a background image. The background image can be created in any visual editor. And on the left side, you see the list of services, and on the on the right side, the grid for statuses and with different units. And to fill in this grid, we need to create, and this image should be uploaded to Zabbix as a background. And to fill this grid, we need to create also icons with states. For example, OK or and problem or something like that. The very important thing that these icons should be, size of these icons should be compatible with the grids, because all of these images. Sorry. What is inside? Two important options. It's icon label type nothing, because we don't want to see labels on this map. We already have it on our icons, OK and problem. And another one, mark elements on trigger status change, should be disabled, because it's not convenient to see arrows when something changes. It's just for convenience. Each cell of the grid linked to submap. And there are 2 drilled down submaps under the dashboard. Service level and the pool level. What else inside? Each cell had the following configuration. Here we set an icon, standard icon for state OK. We use advanced icons, icon problem for problem, and actually you can use also maintenance if you like. It's up to you. We don't use it, but we can. We can show maintenance on the dashboard. When we see the dashboard from user side, we can click on each cell and go to submap. When we go to submap, we see, on example inbound calls again, 4 pools which provides this service in only one unit. For example, unit 01. All these pools are also maps. I mean type map. And when one of these pools becomes problem, change status to problem, the upper level becomes problem here. So let's go inside a pool, and on the lower level we have triggers. This is critical triggers for each pool. So when one of the trigger becomes problem, the upper level becomes problem, and then upper level becomes problem. So that's how it works. Here better to use only triggers, not hosts, because we don't want to see any small issues with the hosts. So let's see this board in action and this picture again. Actually, this is a real example of outage in RingCentral which happened some time ago. And when we saw this picture, we didn't waste time to any investigation. We make decision very fast. We switched to reserved units. And that was very effective approach. We can have a long discussion about advantages and disadvantages of this approach using Zabbix map. But it's just our vision. We can recommend it for you. The best advantage of this approach is this solution from the box. We don't need to develop any additional tools. And until Zabbix provides us a feature to create a customizable tables, customizable dashboards, we can use this or create a standalone web application. But I said again that this is a solution from the box and it's great. And also, of course, we have some disadvantages here. It's only 2 states, OK and problem. And so if you want to set warning at risk or something like that, we can do it. Only 2 states. In our scale, we use problem means outage which already happened. But we also can use, it's our goals worse. It was our goal for now. It will be developed in the future. But you may use, for example, at risk, and that means outage is not happened right now. Another disadvantage, we fully depend on background image. It means if we want to add new units or new service, we have to create another images. Another one, big amount of submaps. So in RingCentral we have about 20 services and about 10 units. That means number of submaps more than 200. But actually, this dashboard can be built in 1 month with 1 man working on this. And the last one, which I can notice, is we can't see history of the dashboard, what outages was there. So that is our vision. That's it. Thank you very much. Questions?
Was it not a better approach to make some kind of extension to the actual web interface?
Yes, of course, we can make another standalone web application, you mean, to build such dashboard?
Not an application, but like in the front page where you can put in your fancy stuff, I would have...
Yes, we can, but as I said, it's just solution from the box. Of course, we can make another page which will show the same, but with any additional info.
Why? Because you have a huge amount of submaps you need to maintain, yeah.
Yes, I agree, but if you will do additional page, you have to do about the same, but not submaps. You need to create pools, you need to create triggers, and you will do about the same, but not maps, but another storage, data storage. I use maps. You will use arrays for this. I believe it's not very more faster than my way, really.
No.
Thank you. Anyone else?
About the aggregation functions, did you ever face any performance problems with them? So group sum or...
You mean reducing performance?
Yeah.
No, performance is not degraded because of this, no. Okay. We haven't issues about this.
Is it a problem to use these aggregation functions not only based on host groups? I think that was a limitation before.
No, as I know, according to documentation, it's not very heavy. It's heavy to use aggregation functions like not on the last value, but on the values for last hour. And according to documentation, it's heavy queries. But if you use only last values, it's light. No degradation.